Or we're going to go ahead and find all the solutions of cosine of x plus 1 equals sine of x. And as you can see here, our we're trying to solve right now, but it's not in terms of either all sine or all cosine. It needs to all be in terms of one of our 6 trig functions. And so the way that we do that is because right now we don't have an identity that we can just go ahead and just straight substitute, is we're going to square both sides. And then from there we're going to convert it into a quadratic type. Hence, that's why the title is squaring and converting into a quadratic type, you know. So here we go. Let's go ahead and square both sides first, and then we'll go from there. So I'm going to go ahead and just write this as cosine of x plus 1 squared equals sine of x. I'm going to square that whole thing. So all I did is I just took both sides and I squared it. Well, if I square cosine of x plus 1, well, that means cosine of x times cosine of x plus 1 times cosine of x plus 1. And that right there gives you cosine squared of x plus 2 cosine of x plus 1. And the right side gives us just sine squared of x, but since I want to put it all in cosine, I can rewrite sine squared of x as 1 minus cosine squared of x. Let's go ahead and subtract 1 to both sides and add cosine squared of x to both sides, which means now I'm going to have 2 cosine squared of x. Drop down my 2 cosine of x, and the 1's just cancel. If I'm going to solve now, I'm going to go ahead and factor the left side. They both have a common factor of 2 cosine, so I'm going to factor out 2 cosine of x. So 2 cosine of x times cosine of x gives me back my first term, and 2 cosine of x times 1 gives me back my 2 cosine of x, my second term. So now I set each factor equal to 0 and solve. So if I do that, this guy right here becomes 2 cosine of x equals 0. And this guy's cosine of x plus 1 equals 0. Which means that we're trying to find the cosine of what equals 0 by just dividing by 2 on both sides. And cosine of what equals -1. Well, just by knowing the unit circle, these can be derived very easily at pi over 2 and at 3 pi over 2. And cosine of -1, let's see, 0, it'd be just at pi, right? At -1, 0, at pi. So now, interesting enough though, if we wanted to check our answers, wouldn't we just plug in these values? Pi over 2, 3 pi over 2, pi. I can plug in these 3 values back into our original equation that was given to us, right? And actually, we need to check our answers for this specific problem. And you say, well, what's so special about this problem? Well, say because we introduced a new mathematical operation. I mean, there was no square root here, meaning we didn't like undo a square root, so we squared both sides. We just say, you know what, let's just square both sides. It's mathematically sound to do that. However, if we ever introduce a new operation that already doesn't exist within our problem, such as like right now, if I did -1 to both sides, we don't need to check our answers. But there was no square root, meaning I wasn't trying to undo it or anything like that. So we need to actually check our answers for what we call extraneous roots. And you should have learned something about this in even Algebra 1 and Algebra 2. So we have to go through the work and check all 3 of these answers. Okay? And we're going to do this rather quickly here. So cosine of pi over 2 plus 1, is that equal to sine of pi over 2? Well, cosine of pi over 2 is 0 plus 1, and sine of pi over 2 is 0.01, so that's going to be 1. So 1 equals 1, bing! So we know that pi over 2 is an answer. That's fine. Let's check 3 pi over 2. cosine of 3 pi over 2 plus 1, is that equal to sine of 3 pi over 2? Well, sine of 3 pi over 2 is going to give us 0 plus 1, and sine of 3 pi over 2, I'm sorry, cosine of 3 pi over 2 is 0. Now, sine of 3 pi over 2 is negative 1. So 1 does not equal negative 1, which means 3 pi over 2 is actually not a solution. Even though we derived the solution, we're checking them to make sure that they indeed are really true. So really what we call 3 pi over 2 is an extraneous solution, which just basically means it's not even real. Like it's not part of the solution here. Let's just check pi now. Cosine of pi plus 1 equals sine of pi. Cosine of pi, that's negative 1 plus 1. And sine of pi is 0. So 0 equals 0. Bing! That's okay. So really, the only answers that we would write down is only pi over 2 and pi. Those would be the only roots within the interval 0 to 2 pi.